Okay, I'm Daniel, and from now on, I'm going to introduce the robot manipulator of each function in DIATwin. This is today's agenda. We have 5 topics. First one is I will teach you how to use the robot manipulator in DIATwin and what kind of function we provide. And second, we can use the traditional method to teach 3 points for establish a user frame. And at the third part, we have a path demo tool to generate the linear path from CAD file. And the first one, we gonna introduce what kind of scenario we might face during using the path demo. And at the final, we can have a experiment for export the delta log program and also the point table to our real machine. Okay, let's go into the first one, and we gonna. I think we just finished the course yesterday, so we can quickly go through it. So this is the simple DIATwin instruction, and we do have this kind of analysis tool like oscilloscope. So the user can find that each joint movement and can get each time state of the position, and later on we can export this kind of oscilloscope data to our own algorithm or our own system to analyze each joint statement. And secondly, we have this kind of Gantt chart tool to find out the tick-tock time of the machine and which part is the battle movement of the machine. So we can analyze this kind of equipment right here, UPH or the cycle time. Okay, and if you open the DIATwin model library, we have an online library over here. So we can find that, okay, there's a robot. I think there's a robot here. Model library, and it is for online official robot model. So we can have different brands like Delta, Denso, Epson, Fanuc, and so on. We have already integrated a lot of robot type inside. Okay. And when we click to our program tab, we have subprogram page, we have a program statement, and we can adjust the statement of each properties. And later on, we will gonna deeply introduce the each function. Okay. Can everyone have to import or open? Everyone still open the POC device, right? Let me create a new file and don't save, or just open file to find out there is a model we just downloaded. This one, CH01 PNP machine tutorial low code. This one. Post start set and open the other. It's over.
เสร็จแล้วแปลงลงแล้วเรื่องค้างเนี่ย
Okay. Where we import in the machine, we can jump into our. Okay, let me introduce with a slide. And first, we can go to the program tab, program page here. And if we click the job, we can find that there's a dragger at the tool head, in front of tool head, and it represents the X direction, Y direction, and also the Z direction. So if we drag the direction from here, we can do the linear move. It's kind of like you drag your robot and directly control it by your hand. And if you use the dragger, you can also do the X rotation over here. You can find that there's a X, RX, RY, RZ. So, okay, here's a quick demo. If you like to use a dragger, you can find that, okay, there's this kind of dragger in 3D World, so you can drag and drop, so or modify the RY position, X position, Z position, and the robot will go to the points you want by this kind of manipulation. Is that okay? Do you face any? If you face any problem or issue, please let me know. Okay, this is a simple instruction of the 6-axis robot manipulator. So the robot is composed of the rigid links, like we have a base link, we have an upper arm link, we have a forearm link, and also it will assembled by 6 rotational joints, which means we have joint 1 over here, joint 2, 3, 4, 5, 6. It will compose as 3 degrees of freedom, which means you can put your right hand thumb, and the thumbs will be the Z axis, the forefinger will be the X axis, the middle finger will be the Y axis, and we can know that because we have 6 joints, right? So we have 6 degrees of freedom, which means the X, Y, Z direction, and also the RX, RY, RZ direction of here. So this is a quick demo for these 6 degrees of freedom. And secondly, if we're using the robot, we typically use 4 types of coordinate system. The first one is joint coordinate. The joint coordinate means we can directly control the robot by each joint. If we want to let the joint 1 to the specific position, we can just change the number, and it is the simplest one. And second, we have a world coordinate, which means there is a world coordinate over whatever in 3D world. We have to focus on, if we're using the real robot, the world coordinate, which also means the robot base. But in our virtual environment, we have a world position over here. So there's a little bit different between that. Please remind it. So if we talk about the world coordinate system in a virtual world, we have to be careful about there's a difference between virtual one and the real one. Okay, and the third one is user frame. this is a frame defined by the user. So, for example, if I want to like process this mouse, and I can create a user frame on it. It's like it's not good example. I can set a frame origin over here, and this is my robot, right? I am a robot, and if I want to define user frame at here, what we can do, we can set a comment to the robot and go to this user frame 000, so we can export the points by this user frame, so that when we modify the position of this product, we don't have to reprogram again, because the frame will give us the info that the position between the frame and the robot. And it is what the purpose we're using user frame. And the final one is called tool frame, because we gonna use different kind of an effector to doing the operation, right? Like when we're using screwing, when we're using spraying, we have different kind of guns and tool head. So we can define different kind of tool head to using by different end effector. For example, we defaultly we have a user frame 0 at the TCP point here, and if we connect another tool frame, another end effector, we can define a tool frame over here, so we can directly use the tool frame to approach somewhere. Okay. This is the properties of the job function in DIATwin. At the top, we can have the origin position, which represent the current robot position in word frame or based on parent frame, which means from the user frame 0 or from the word position. And secondly, we can change the tool frame we want to observe. For example, I can directly show the demo. Okay. This frame is based on word frame, so we can find that okay, where's the word frame? Here's the word frame, and the number represents the translation and rotation between word frame to this selected tool frame. Okay, and if we modify and now change it to user frame 0, you may find that okay, the number has changed because it is represent the word frame to currently the user tool frame 0. Okay, so if we change it to the parent, it will represent the user frame 0 user frame. We can check that. Here's the user frame 0. Of course, we can use here to make sure that the first user frame. Here we have it. We have a move to a frame or move user frame to observe first the frame we select. Okay. And for the third part is robot configuration. Because we are using the 6 degree of robots, so there are three kinds of posture to achieve with the same point. For example, the TCP point still remain the same, but if we change the configuration, we can find that okay, with different kind of posture, we can still go to the same point with the same orientation. So there are so many kind of kinematics rule to change the current status. And sometimes if you're facing the robot is out of range or cannot reach to the point, you can change the configuration by yourself to try to fix it. Okay, and the final one is we have a jog by next function. I believe during yesterday we already checked it before, right? Okay, but I just want to mention that there is a really important things over here, because the snap function you will find that there is a red axis at here, right? Which means that what kind of axis we want to approach with the tool frame. And if I click here, I can find that, okay, position is out of reach of the robot. It's because the z-axis is not outside. So we have to change the orientation from positively to negatively so that we can use the snap function up here. Yep. So whenever we use the snap function in DIATwin, we have to focus on which tool head we are currently use. The tool head's orientation we currently set. Yeah. Okay. So it is the basic operation of the DIATwin robot. And later on, we're gonna have a quick example to let you guys have a manipulation. Okay, so is there anyone have any question right now by using Rager or Java snap function? Nope. Oh, cool. Okay, and we're going to introduce some motion commands we probably use in DIATwin. First is move P. It's called point-to-point movement, as well as known as P2P. Yeah, we always say P2P or line. And there's a difference between point-to-point and linear motion, because in the point-to-point motion, the robot will calculate the shortest path of the robot by each joint. So each joint have to rotate the minimum position to achieve the goals. There's a question about it. We couldn't know that the trajectory from P1 to P2. If we want to have how can I say, a predictable trajectory, we have to use the linear motion because it will go through a straight line. Okay, so there's a difference. But if we using move P2P motion, it will be faster and shortest time we can get. So it depends on the situation you want to move. Like if you just want to return to home, we can use P2P. And if you want to have a obstacle avoidance, you can just use the line motion. Okay, so let me walk through to the program editor. We have so many kinds of movement or statement in our DIATwin. As we mentioned, linear motion, P2P, joint motion is mean we can move a single joint. We can set like joint 1 to 90 degree, and we have a touch up. We can override the current position. For example, if we just randomly create a point, and later on, I gonna change to another position. I can click here and touch up. So the point will be override from the current position. And of course, we have using the weight DI and DO signal, right? Here, with DI statement and set a DO output. And also we can code a subprogram to run the subprogram from the list. We can add our subprogram by and change the name like test one or something. And we can drag the position from program editor to some of the subprograms. So okay, it's what we using for what we use to create a subprogram like this, so that the position can be the range can be modified, and when we click the motion, it will go to the test one like this. Yeah. Okay, so this is the way we using code subprogram, and we can also assign a variable like XYZ, whatever we want, and we can use the variable to accumulate the like interact with the IJ, or using the while loop, if loop to do the statement change. Later on, we're gonna have a example about it. And also we have a delay time over here, so we can insert a period delay at a statement. Okay. And we can start a timer, which means that we can observe the robots will, how many times will a robot cause. Here. Okay, so if we just run this statement, we can find that, okay, there's a timer start over here, and within this P2P motion, we got a timer about 0.040, that's 64 seconds. Okay. And also we have a tracing function because we would like to at least see. So differently. Wait a second, please. If we're using the trace demo, we should have a tracing trajectory of the TCP. And let me check it after that. Okay. So usually we're gonna use a different kind of control method like P2P, IO, delay, and also we can insert our logic like if else, loop, variable, this kind of method. And we can find that there are so many subprograms in this example, right? You can directly press the simulation. To see what's going on with this example. Okay, you guys can try it to run the simulation. Okay, 去面，地方这头，你是地方这头，那不上找地方上面，我都去那里面弄你们确定要打过，一公里，有多少？啊，哪个？啊。 And we can find that there are so many subprograms over here. We have move track, we have stop the conveyor, we have pick object statement. So you can find that if the robot goes to pick something, the current statement is gonna try again. Wait a second, my projection was shut down.
Maybe you can try with the example first. I got this your simulations running. You also can observe the local process when you are under the simulating. You can see here's the process when you are running. You know what storage? Also. No, this one is not okay. I mean, you can see when we implementation. Here's the status, and right now we are running the delay statement. And also with we have for from main process you can see by process. But because we also display it as a subprogram. Here we have running so we can then reuse the function by using this kind of function. So maybe while using that forward and force so many product, you can just use something to combine to the product. But it's also if you have this kind of arrangement, we'll also have to learn some way to alter the robot points. Yeah, but the software will be exactly the same. Oh yeah, in the behavior, not for the conveyor. Under testing. So here's the speed. That's the proportion. Speed proportion here. Yeah, to be 4 or 20, you can find it will be very fast. The maximum is 100%. The minimum is between 0 to 100. Yeah, it's the best. And also it's the absolute control. Then actually, I think this kind of value is not possible. It's not enough to simplify. Too fast. I can try to be faster because I'm carrying some stuff. Okay, we said it again. We said it again. Yeah, you can see clear time. That's why so then you can do this. Firstly, the type of reading. Moving to select the device. The X, the option.
Okay, let me simply introduce each subprogram. With the move track, we can send the digital output to the conveyor to let the conveyor knows it will be start. It's gonna start and wait for the sensor trigger to know that okay, this conveyor already moving right now. Oh, and also we have a sensor over here to know that where's if the conveyor here, there's a distance sensor. So if the object touch with the sensor, we can ask the robot, ask the conveyor to stop it. Yeah. When we receive a signal from the sensor, we can ask the conveyor to stop it, and then we can ask the robot to pick the object. We already teach some points and use a signal digital output to activate the gripper to make a movement, and then wait for 0.5 seconds to grasp the object and rest it. Okay, and also we can call the place object to the conveyor one and place the object, right? And it of the process flow. And there is a tip to how to teach a point if we want to put the object on the conveyor, and we couldn't know without running a simulation, right? We couldn't know the position without running simulation. So what we can do, we can use the motion capture over here. We can set the motion capture. Sorry, we have to reset the simulator.
This function is like replay the simulation for you. So you don't need to execute the simulation, but the replay recording will be recorded in this function.
你要跑那种，你要勾到那要勾啊，你要勾，还是不是我先新增？不用了，目前这个了，什么？这个没有，你静态的调新增，更可以对。那你等下重复弄一下就跑出来。OK。
And if you like to pay back to the specific position, we can find a time step.
Reset. You can find the recording that
so that we can know that the conveyor will send the tray to this position, and we can use the jog function to teach a point of the robot. Like here, if we want to modify the position, we can like this and set a point. So you can teach the point by this function, by this motion capture.
Reset simulator. Then if you're going to reset, so you can select the frame of the playback. Motion. Enable English text. Let's do the simulation. So they will record the playback of the simulation.
直接在那边调完回家，然后就会记录起来。但是它只是
但是 you can just go
在3D世界里面可以点到那个上面，然后把它存起来。
用那个，然后
you can check out what the simulation in detail happen. Like we are able to with what is this one because we don't have any way of aligning it, but we can use this frame to make this part of start at the great point. Yeah, so there will be a great reference for you to teach the robot. Yeah, okay. You can use show that only, so you will teach it with okay.
你直接用那个跳销，
也可以。
Okay, so you can use
这样子也会对应到我这边教的那个头盔，然后去换掉它的点。
你要去找到某一个点才能跳销。
它才 override。
Every point，
这是我们的 space software， 然后这里 space objects 的。
Running is for sensor detecting from object. So you can use this
来去讨巧这
to
去点它，然后先去移动时间来讨巧。
一直都 use the touch out because when we set the measurement, actually it will set with the first frame. Like we have this object when we start simulation. So I want this one. So when I set the disappear, so I have to use the motion capture to find out which movie I want.
Okay.
Yeah. So that's the replay function for you. So because in this stage we are not under a simulation, so we are going to alter the properties of the program.
Okay. And based on this example, we have a quick exercise. So we want everyone to generate another object and put it on the left side. We can create one more object and put it on the tree. And because for the time limitation, so I'm gonna walk you through how to create it. Okay. And this is the origin. We can have only one object, right? So first we're gonna find the feeder. Here's the source behavior, which is talked about yesterday, and we can have a signal input or using timer to generate an object. For example, like we can test about it. Okay, now we have another one. Of course, we can use the manual mode to receive a detailed input, so to create an object. But for a quick demo, we can use a timer to create another one. And second part, if we have an object over here, we have to modify the sequence, right? Because currently we only have a pick and place for the first object, and so we can duplicate the sequence like pick object. We don't have to, only have to modify the place object. So we can copy the sequence and rename it as the pick object 2 and check it with what happened right now. Sorry, I forgot to add the sequence to game place object 1. Okay, so we can call a subprogram like pick object 1 and also place the object 2, place object 2. Let's find out what happened right now. Okay, now it's moving track. Now it's pick and place this object 1, and now we can pick another object, but the position is still it's not right. So now we're gonna do is change the object to position, so we can find out there is a prepare point, there is a placing point, there is a safety point, and we go back after the movement. So we have to modify these three statements to the position 2, right? How can we know the position of another slot on the tray? We can use a capture, right? We can know that, okay, there's a here we can directly move the position from here to like 50 millimeters, or we can directly move the position. Like we have a measure tool, right? So we can know that, okay, from point to point 2, we got 46 millimeter. So we can directly modify the position by 46 millimeter. 46 millimeter and touch. And also 46 millimeter. So, or we can use the object mode to move the full frame, like minus 46. And the position will be changed from now. Sorry, we have to modify this one, minus 46. And jog again. Okay, it should be fine. Let me check it. You can place for the object 1, pick object 1 to the position 2, and yeah, that works. Just a quick demo. So there are some tips. First, we can modify the feeder. We can modify the source behavior from DI to timer. Second, we can use motion capture to teach a point on conveyor. And third, we can duplicate. We can copy the sequence and directly touch up or modify, overwrite the position. And secondly, we can finally we can use this kind of measure tool to know that the distance from point A to point B. So we can directly modify the position of the statement. Okay,